Hey, 6th grade. Today we're going to be going over ice cores, reading about ice cores, and then using data from ice cores to find some interesting connections between CO2 and temperature. Quick reminder that tonight you should be watching the video on the carbon cycle and taking notes. It's really important that you take notes on the carbon cycle tonight. Make sure you have your notes for class tomorrow. To start out, let's read about ice cores. To find the ice core reading, go to Google Classroom and find the ice core activity. In the classwork section of climate change, you should see an assignment that says ice core data analysis. Open that up and find the Google Doc called ice cores. Here's the big question we're going to try and answer. How do we know that climate change is happening? How do we know what Earth was like a long time ago? And how do we know humans are responsible? Those are our big questions during this reading. To help answer those questions, a big part of the answer is ice cores. In Antarctica, scientists have drilled down 2 miles below the surface and brought up samples of the ice. The ice cores are long tubes of drilled ice. It's like what you get if you stick a straw in a Slurpee and pull it out with your finger over the end of the straw. What you will have inside the straw is like an ice core, although a very slushy one. Here you can see scientists working in Antarctica, and they're pulling up these tubes of ice. Those tubes of ice are called ice cores. The layers in an Arctic ice core are frozen solid. They give clues about every year of Earth's history back to the time the deepest layer was formed. The snow that falls each year traps small bubbles of atmosphere. So each layer of snow contains a small amount of the atmosphere for each year going back 400,000 years. Wow. At the very bottom of the ice core is the oldest air. Air gets trapped in the ice. And so as you go up the ice core, as you move towards the surface, the air becomes newer and newer and newer. So we have a record of the air going back 400,000 years. The bubbles in each layer of ice hold clues about the climate of Earth in the past. Scientists analyze the bubbles in each layer to see how much CO2 they contain. Scientists can also learn about the temperatures for each year by measuring relative amounts of different types of oxygen atoms in water of the ice. Remember, water is H2O. H2 stands for 2 hydrogens, and the O is 1 oxygen. So from an ice core, scientists can figure out how much CO2 was in the air and the temperature of the air going back 400,000 years. During cold periods of Earth's history, the oxygen is slightly different than during warm periods. Give yourself a quick check-in. Try and answer in your head. What are ice cores? How do we get ice cores? And what data do ice cores contain? For today, we're going to try and answer this question. How could we find information on the temperature of Earth from 400,000 years ago? We know that the information comes from ice cores. But what does that information tell us? To figure out what ice cores can tell us, we're going to have to do some data analysis. Again, in the classwork section of Google Classroom, go ahead and find the Google Doc called Ice Core Data Analysis and the Google Sheet called Ice Core Temperature and CO2. Have both of those open. What you're about to do is look at a virtual ice core. The information in the virtual ice core is the actual information that NASA scientists have been using to determine the changes to Earth. In the virtual ice core video, you're going to gather data on the temperature and CO2 concentration over the past 400,000 years. You're going to enter that information into a data table. As you finish your data table, it will create a graph. You will copy and paste your graph into the Google Doc called ICE Core Data Analysis. Once you have your data, you can write your CER. The last piece of data you'll need is the data from today. Compared to historic temperatures, Earth is 1.2 degrees Celsius warmer today than it has been, and the concentration of CO2 is 416 parts per million. That's what ppm stands for. During the experiment, you're going to try and answer the question, what is the relationship between CO2 and temperature? To complete this assignment, the first thing we're going to do is fill out the ICE Core temperature and CO2 graph. To do that, you're going to have to open the YouTube link with the ICE Core information. It's linked in the Google Doc. When you open that link, you'll see information from the ICE Core. You're going to enter the information into your Google Sheet. I've done the first 3 bubbles for you. What this is telling you is that 400,000 years ago, the Earth was 1 degree warmer than normal, and the concentration of CO2 was 275 parts per million. In the second bubble of air, the ICE Core tells us that the temperature was 4.2 degrees cooler than normal, and the concentration of CO2 was 190 parts per million. The third bubble in the video shows us that Earth was 1.6 degrees warmer, and the concentration of CO2 went up to 245. Continue watching the video to fill in the remaining information from the ICE cores all the way up until the year 0. Reminder that in the year 2021, Earth is currently 1.2 degrees warmer than normal, and the concentration of CO2 is 416 parts per million. Once you've completed your data table, click the tab in the bottom of your graph, and you will have a completed temperature versus CO2 concentration graph. This shows you the connection between CO2 levels and temperatures on Earth. The black line shows you CO2, the red line shows you temperature. You'll need to click the Copy Chart button, then go back into your Google Doc and paste the chart where it says Data. Now that you have your chart pasted into your Google Doc, you can answer the CER. Again, the question is, what is the relationship between CO2 and temperature? For your claim, you might want to use the sentence starter as CO2 goes up, then temperature, ... Make sure you provide evidence from your graph and use reasoning from your notes. Good luck, and make sure to use your time wisely.